Hello everyone, my name is Marcus Nordqvist. I'm the CTO of Happy at Work and Queen's Lab. This is me drinking some tea, and today's code launch is going to be a little bit different because I'm not going to show any actual code. Instead, I'm just going to talk a little bit about Svelte and how come we love it. So basically, comparing Svelte to other JavaScript frameworks, you might think that is it just another JavaScript framework? Well, actually it isn't. It's a little bit different, and I would say that there are a few other options that are similar to Svelte, but by far Svelte is the most known with a very fast growing community. Svelte is a compiler as framework type of JavaScript framework. And that means that we really don't have any runtime in the natural meaning of the word, because what happens to Svelte components is that they're actually transpiled into vanilla JavaScript. And another positive thing, or at least something that I think is very positive, is that with Svelte we don't have any virtual DOM tree at all. Instead, all changes are directly updated in the actual DOM tree. We also compile the Svelte components, or the Svelte files, with a file ending of svelte directly, and we don't look at any application from a holistical perspective. Instead, the components are compiled by scope. Svelte is truly reactive compared to, for instance, Vue or Angular or React, where we have a virtual DOM and we actually traverse the virtual DOM to check for changes that has appeared and then apply them in the browser DOM. I also have this number with 40% less code than React, which is kind of biased because the number is actually taken from Rich Harris, which is the original author of Svelte. But taking a look around and just trying stuff out, I think that it's a pretty accurate number, to be honest. And Svelte has still a small community. I already mentioned that, but it's still a small community, but it's growing really fast, and I'm one of the supporters. One of the curious things about Svelte is that the framework was originally actually written by New York Times graphic designer Rich Harris, and you have a reference to his GitHub here in my presentation. So comparing Svelte to React, I already touched upon it a little bit, but while React uses a JS engine at runtime, so you actually reference React in runtime, Svelte kind of compiles itself away because there's no reference to any framework file or anything like that in the runtime. Instead, what is left, or what we're left with, is vanilla JavaScript. So that's one important thing. So if you look at the chain here, how it differs from, for instance, React, Svelte files are compiled, or Svelte components are compiled into vanilla JavaScript, and that vanilla JavaScript surgically updates the DOM. And what does that mean? It means that any changes that happens when you click a button, or when you hover an element, or whatever it may be, updates the browser DOM instantly, instead of, which is the case in React and in Vue or Angular, that we update the virtual DOM and then we iterate over all the elements in the virtual DOM, or by using any npm package out there, you might actually look at only a part or a section of the DOM. But regardless, we need to iterate over the nodes in the DOM, maybe not all of them, but a portion of them to look at the changes that has been made. So we look at the virtual DOM and we see whatever has been updated should also be applied to the browser DOM. Any proponent of the virtual DOM would pretty much say that the virtual DOM could be more effective in the diffing process because it actually calculates the best way to operate and to update the browser DOM. And it can also be updating the browser DOM in batches and doing this the best possible way, and that's why it could be more efficient to use a virtual DOM and the differentiation engine to update the browser DOM. But if you already compile it and calculate the best way to surgically update the browser DOM, then it will be much faster, and it will be very difficult to compete with that. So what actually happens then with Svelte? Well, this is the compiler, and you can dig into the actual workings of the Svelte compiler more deeply. I'm not going to go into the details, but basically what happens is that Svelte files are compiled into an abstract syntax tree using the Acorn npm package. It then compiles the CSS using another package called the CSS3, and traverses the whole abstract syntax tree using another npm package called the ES3 Walker. The compiler then generates vanilla JavaScript from the understanding of the application, or the components actually that we have at this point, and mounts those components into the actual DOM tree. Available here in the slide is also a reference to a micro version of the Svelte compiler made specifically to enable you to understand how the compiler works. So it's not a full compiler, only a subset of the instructions are available just to give you a brief understanding of how the Svelte compiler works. Obviously, Svelte is also open source, so you can download it, or you can clone the full GitHub repository as well. And then there's something called SvelteKit, which I'm going to touch upon a little bit later. I don't want to bash on React. It's just that it's a good, since React is so popular, it's just the easiest comparison that can be made, because a lot of people are familiar with React. And I would say that there are a lot of areas that React covers, and there's a lot of components for React, and it's definitely a very good framework. So Svelte is not nearly as popular as React for many reasons, but I would say mainly it's because Svelte is pretty much unknown to the majority of front-end developers out there. So getting back to what is the problem with the virtual DOM, let's imagine that you have a few thousand nodes, which is not necessarily even a big application. You can have tens of thousands of nodes in your application, or in your HTML document rather. And if you're going to go through all of these nodes, first of all, what is the virtual DOM? You have a shadow copy of what is the browser DOM. It occupies memory. And besides, it also requires a lot of operations to go through each and every of these nodes and look for changes and then apply them in the real DOM. There are many reasons why this was the case, and this still is the case in many ways for front-end applications, and why we have a virtual DOM. But I think that the approach that Svelte has chosen is actually a very good one, and it solves a lot of problems with the virtual DOM. Also, it becomes obviously a lot more responsive, and it's difficult to defeat Svelte in this area, because when you're making instructions that directly updates the DOM and there is no shadow copy, obviously it would be a much faster approach. So less code, we talked about this a little bit before, like about 40% less code. And if you take a look at this example, these two examples at the top here, code snippet 1 and 2, solves the same thing. And this is a comparison, of course, between React and Svelte. But there's also a lot of other cool stuff going on here. So let's take a look at the await posts code snippet down to the left, where we have a promise that an awaitable promise called posts. And this is a cool statement, I think, in Svelte, where we actually await the promise, and while it awaits the promise, we're loading. Well, then when it's done, the payload coming from that promise, or the payload that is evaluated from that promise, is then an object that we can use. We have the data object on the payload object. Probably this is a response from a web server or REST API of some sort. And then if an error occurs, then we show something else. So this is a conditional async await implementation in just a few lines. And I think this is a very neat way to do conditional display of messages depending on what stage a promise is in. And the $: means that we have a reactive statement, which means that in this case that bar will be continuously updated depending on the foo variable, which is a neat trick. So if we decided to print the bar variable, it would continuously update depending on the foo variable. So if we change it through an input field or a slider or whatever component we might use to update the foo variable, it would continuously update the bar variable because it's a reactive statement. So to summarize why we love Svelte, well, less bundle size, it's definitely more performant, consumes less memory, requires less CPU, and as displayed before, less code, which is, I think, some of the most important things, or one of the most important things is that we have less code because it makes the developer experience much better. These very simple benchmarks displays how Svelte is completely untouchable from the other big frameworks out there, Vue, React, and Angular. As we can see, the script boot up time is superior, total kilobytes in weight is superior, read memory, run memory, update each 10th row for 1000 rows, 5 cycles, repaste 1000 rows, 5 cycles, creating or clearing 1000 rows, 5 cycles. These are a selection of benchmarks. Of course, I don't want to be dishonest, but I do believe that Svelte in many ways, when it comes to performance, is definitely superior. Also some data about the interest for Svelte and how it has grown from 2019. It's a very young framework, as you can see, but the interest is very high. And interest in this case means that people that have worked with it and are willing to stick with it, or people who are just interested in pursuing it further. Also satisfaction, people who have worked with Svelte and will work with it again. And this data has been taken from State of JS, and this is the latest data from 2020, and you can look it up for yourself. The reference is in the presentation here. So yeah, that's a little bit about Svelte. And then there's a second framework, adjacent framework, which is called Sapper. And I'm not going to go too far into depth about that, but when we're talking about static site generation and server-side rendering, which would in React and Vue would be Next, Nuxt, or Gatsby, or any of those similar frameworks, Sapper is the Svelte correspondent framework. Sapper also offers the support for static site generation and server-side rendering. So this is me, and this is like a very old traditional flow where you know, me as a user, open up a browser, go to an address, the client, or the browser in this case, picks up some data from the server and presents it to me as a user. So this is a Svelte Sapper example, where we have a Svelte app, which is the front end part of the application. So the Sapper is actually a Node.js application running on the server. So what happens first is that Sapper will preload maybe some resources, perform some actions, and return components into the Svelte app. And the Svelte app is running in the browser as a vanilla JavaScript application, displaying data and a user interface to me as a client. Let's take a look at a brief example what we can do. There's a very simple Svelte template, and you can digit it here using npx. So let's just test this out and we'll see. So npx digit svelte.js -template svelte-app. And you see it starts working. Destination directory is not empty. Obviously I need a directory as well. So let's create Svelte example. Okay, and we'll dive into that. Okay, so this directory is empty. So let's try to digit it again. Then let's open up this up in Qode. So yeah, all right, now I have the Svelte up here, and you can see the structure here. We have something called a rollup config here, readme file, and you can take a look at it formatted like this. It states some how to install the dependencies. At this time we're using npm, but yarn works just as good. Also how to start it, and how we use TypeScript, because Svelte obviously also offer TypeScript support. How we simply deploy it to Vercel, and some other commands. But let's just focus on, first of all, installing the dependencies, and building it. All right, what is this? Maybe it's because I'm in the wrong folder. Yeah. Obviously, I missed to install the dependencies as well, because I was in the wrong folders to begin with. So I need to do that again. And now we're building it, and you see that it's built, and I have my bundle, which is displayed here under build. I have the JS bundle, the CSS bundle, and a map file for debugging. So if we take a look at the index.html, we see that we have a reference to the bundle, and the bundle JavaScript, and the bundle CSS, the global CSS, and the favicon. So everything is here. So what happens then, if we take a look at the package.json, we can see that we have a few scripts here set up. You see that we have a build, dev, and start. Of course, this works. This three works a little bit differently. The build is obviously to build and to produce the bundles, whereas dev runs it as is, and start uses the built bundles to start the application. You can also see that we have something called rollup here. And what is that? Rollup is something similar to Webpack, and there's also something called Parcel, Cube, Snowpack, and so on. So let's see what happens when we run the dev version of the application. So I'm just gonna write npm run dev, and I'm gonna execute the dev script. Such, and there we see your application is ready. It's running on localhost 5000. I'm gonna hold control and click. So for some reason there's I think we're missing a font. but let's not worry about that for now. Let's see if we can just move this a little bit. Let's move it over here, and then maybe we can take the Visual Studio Code and move it all the way over here. So there we go. Okay, so let's take a look at the application here. We have hello name, and we're using an exported variable, which means that on this app.svelte, this is a variable that can be set from the outside. In this case, it's set here. You see that we produce the app like this in main.js, which is the entry point for this Svelte application. Where we have the props object here, and we set the name variable. We can also set name2, and name2 it's gonna be Marcus, and in the app Svelte I'm just gonna change this to, actually I'm gonna add first, I'm gonna add a name2 property, and I'm gonna use the name2 property instead, and I'm gonna save all, and then you see that it instantly updates to Marcus. Can also see, I think this is Times New Roman or something. It's not supposed to be by default, or is it? Yeah, it doesn't really matter. Let's say that we change this to font family, and we use Helvetica for this, and you see that it changes instantly as well. But then let's go back to our presentation. Sometimes, I think it was October 2020, when Rich Harris made it public that Sapper would not see the day of light, or let's say Sapper 1.0 would not see the day of light, and instead the community would focus rather on the development of SvelteKit, which is kind of Sapper and Svelte in the same package, more or less. And that's a good thing, I think. Rollup was the default build tool for Svelte apps, while as I'm not really sure exactly how everything works, but I would say that Snowpack is a post-install tool rather that was introduced in with SvelteKit, and is now used primarily for development with a really good hot module reloading, and it's pretty fast, I guess. I've been using it a little bit just for test, and I think it's really nice. You can use it in combination with Webpack for build and minification and stuff like that. I'm not going to go into depth about what Snowpack is and SvelteKit, but it's coming, and I hope that SvelteKit 1.0 is released in 2021. So one case that I wanted to introduce to you is the Happy at Work case. As you might know, I am also the CTO of Happy at Work, and I still do a lot of coding, and I have been quite involved in the development of the administrative user interface of Happy at Work. It's quite good, actually. I don't think there's like any real major flaws in it, but just being the person I am, and I want to make it perfect, and we've always talked about the Class A service. I think Happy at Work is pretty good, but we have some work to do when we're moving into latest technology, and we have some great ambitions with the Happy at Work administrative user interface. So when I was thinking about changes that our clients wants us to do in the user interface, I just decided that this is the best point of the Happy at Work lifetime, where we can possibly move from Vue.js to Svelte. So we're using instead a Svelte Sapper solution, to build the new user interface, or Happy at Work 2.0. Well, it comes with some downsides. I can't one of the reasons, let's say like this, one of the reasons that I decided to do this change is that now that we're writing the new user interface, we're not gonna bloat it with a lot of npm packages. We're not gonna install pretty much anything, but we want a more or less a pure vanilla JS application. We're also using a Redis distributed cache. And since Sapper has the possibility of jacking this Redis cache into the middleware, I just thought that would be a really good idea, and that's when we came up with what I call the pinches data transfer pattern. I haven't seen this this way of working, at least with a front end, explained as a pattern or a design principle before. So obviously it might already have a name. It's not serious at all. It's just kind of a joke, and that we have something to talk about or around to have a terminology. But the pinches data transfer pattern pretty much means that, okay, what happens here? We have a user interface and we have a Sapper app that in coding time or in compile time, Svelte and Sapper app, they're just the same thing. They're the same entity. But as soon as we're compiling it, we actually have a Node app running on the back end, and we have a Svelte app that runs on the client side. And what's going on with the data transfer pattern here is that Pinchos, first of all, is a restaurant where it's a Swedish restaurant, Swedish Mexican restaurant or something, where you order using an app on your phone. So you go to your app on your phone, you order, and then you get a notification when your food is ready, and you have to go and pick it up yourself. And I think this pattern is pretty much the same thing. It's like you order from one place and you go pick it up somewhere else. And this is the idea. So instead of just doing a normal REST API queries, we let the Sapper app actually tell the web API to prepare data. And the only thing that we return to the Sapper instance from the web API is a key, is a cache key. So basically it goes like this. So the client, you're going to a client route or a route on the client side where we have a preload function which runs in Sapper. Sapper goes to the web API and says, look, I want data, I want this type of data, and I want it to be ordered in this way, blah, blah, blah. Okay, and the web API says, fine, I have taken your order, and here is your cache key. The web API will then continue to go into the database and any other source that it needs to integrate with to get that data, to order it in the right way, and to structure it the way it was ordered from the Sapper app. But instead of returning it directly, because it already returned a cache key, it just sets that data in the Redis cache using the cache key that has been returned to the Sapper app. So, and then it continues to just transmit an event to the Sapper app. Like, okay, here's your cache key. We've initiated your order, and then eventually we'll have an order complete. And that could be done in any number of ways. First of all, we already have a SignalR connection in using our app. But it could also be, since this Sapper runs on a backend, it could actually be set up to, the Sapper app could work as its own API with an endpoint that is actually like a webhook almost, that is invoked from the web API. Like, it doesn't need to contain a lot of data. It just says that, your data is ready, go and fetch it in the cache. And then the Sapper app goes to the cache, collects the data, and returns it to the client side. Okay, this might seem a little bit tedious, but let's just consider what's really good about this. If we scale out, I may have any number of web APIs. It doesn't really matter. We don't have any state at all really in the web API. It helps us to remove the state completely from the API. We don't have any tokens on the client side at all. Actually, we just have a session, and the token is saved in the Redis cache actually, but in the Sapper instance. So we don't have a token on front end. There's no man in the middle or anything like that, because everything produced from the Sapper is just data that is already verified in the session. Also, if we scale out the web API, since it's completely restless, we don't have any state whatsoever. It just produces data that it puts into the cache. So it's very easy to scale out. It's very easy to distribute. And as well, obviously I didn't mention that, but before going to, if the Sapper app already has something in the cache, it's not necessary for the Sapper app to always go to the web API and request the same data. There is a caching strategy being implemented at the Redis cache level to make sure that we already have the latest. Let's say that we have, in our case, we have an Azure Service Bus. That's when anything is updated. It is also updated in the web API from any other source, like integrated systems in microservices architecture. So when anything is updated, the web API will directly update the cache. If there isn't anything in the cache already, then it will put it in the cache. So the Sapper app will very rarely actually go to the web API and request anything, only if the Redis cache is empty, given the cache key, or if there is no cache key for that particular object. This is meaning that the Sapper app will pretty much always, or very close to always, just go to the Redis cache and get the data. And that is a lot faster, and it will produce a lot better results than going to a web API or querying the web API with a very complex operation and having the web API calculate, aggregate data, structure, order, whatever it needs to do, sort, and then return the data, which is a tedious and time-consuming process. Instead, the data is already ready for us in the cache. Some references to what I've been talking about. Await as a logic block is available here. There's also something else that I think is interesting to take a look at. It's slots with fallbacks. If you're familiar with Vue, you might be familiar with slots because it's used there as well. In React, we normally use rendering instead, and there is no support for slots this way. But there is in Svelte, and there's also something called fallbacks, which meaning that we can have normal slot functionality, but with a fallback, so that we display something if there is no content set on the slot. And also, I wanted to show you a simple drag and drop solution, because Svelte offers great support for animation. And I think it's called it's a motion. It's a small subframework called Svelte Motion, and it has some support for different types of animation, CSS animations, and I think it also uses JavaScript under the hood. And I just wanted to show you an example of a simple Spring motion demo. So a real quick demo. I'm gonna log into the new user interface of Happy at Work, and I'm gonna go into the organization view, which looks like this. It's still very unfinished, but I do have dark theme. That's what's important, right? So yeah, I'm gonna stick with that actually. Okay, so what happens now? So in this case, I have groups here, and this is the Queen's Lab groups that we have. We have the tags here, and I'm not going to go into detail about Happy at Work and how that works, but let's take a look at Digital Solutions, for instance. And here we have some guys here that I work with, and if I use this, you see that I can just drag and drop. This is a very simple drag and drop. This is the fun thing. It's not. This is the Spring motion included in Svelte. So that's about it. I mean, but it does bring the whole application to life a little bit. I feel that it's like a lot nicer. This motion makes it a little bit more alive than just having it pop right back. We have another thing that I think is interesting, and how easy it is in any subcomponent to set up global key event handler. We can take a look at that, and this is an example. So I'm just going to focus this window, and this is of course could be inside any component. And if we take a look at this, is where we set the key down. So you actually access the window node of the HTML tree like this Svelte window, and I target this window here, and then I can just write any key like this and see that we pretty much have a keylogger. And yeah, of course some styling here, and if key, that's the, take a look at the handle key down. And so we have two properties here, key and key code, and you see that we handle the event, the handle key down event, and we're using that event to set the properties key and key code. And also if key is set, then do this, else it is not set. So that's what we had from the beginning. Focus on this window and press any key, and as soon as we have a key, it will print the key code inside this paragraph element. So moving along, a simple tree structure, also very, very simple. There we go. So in this case, we have a typical folder structure. There we go. So a folder structure that is expandable. The folders are expandable like this, and of course the leaves in this case, in this tree structure, are the files. And the way it's produced is, let's take a look at the JSON first. Okay, so this is the array. We have some folders, and you have the different types, type of file and type folder. And they look like this. And then inside we have a folder component here referenced. The folder component looks like this. So you see that we have a toggle function to change the expanded property to true or false, depending on its previous state. So if it's expanded, it will change into unexpanded, and so on. So when I click the folder like this, the folder also has a reference to the file component, and all the files, we iterate over the files. The files is actually an exported, let's see, it's an exported property here, and it's set in the folder, let's see, here. So we just set the files like this to root, and root is of course this array of objects. It's the whole tree structure. The files, then we iterate over the files, and that's okay. We could probably have a different naming because the files can actually be a type folder, and that's a little bit weird, but anyways. So if we have if it's a type folder, then we reference the same component that we're in, Svelte self, and otherwise we use the file component. Okay, the array that we're iterating over is files. The element that we are at in the iterations is file, and we're just sending it in here as a parameter to either itself, which generates the recursive design here, or we send it to the file, an instance of the file component. And as you can see here, and then we print the name of the file. So that's pretty much it. I think it's a pretty neat demonstration on how to implement a tree structure very, very easily. Last but not least, I wanted you to see a prefetching Sapper demo, and I'm gonna go back to my Happy at Work administrative user interface and show you how we get some data just by hovering over a link. So here we are, back again. So let's say I'm also gonna display the dev tools available to us in this Chromium Brave browser. Here we go. And of course, let's take a look now at the network tab in DevTools when I hover over the home button here. See that I didn't click anything yet, but I did do a prefetch. I just retrieved the dashboard from the Sapper app. And of course, let's take a quick look at how that is presented in Qode. I just removed some code here because it's not really relevant to display, but what is important here is this context module here. This is a script that runs before the component is actually loaded, and it runs on the Sapper app, where we could also have a preload function that does a lot of stuff. In this case, let's take a look at, this is of course the sidebar where I hovered the home button, and this is the home button, and you can see that we do something prefetch. We use the rel attribute here and we set it to the prefetch value, which makes it request the whole page actually, or the whole route, before I even click it. So everything is already done here, and it starts. The stuff that I removed here is like, okay, we get some stuff from the database. In this case, I haven't yet implemented the full data transfer, the pinches data transfer pattern that I talked about before. So I still get some stuff from the actual REST API. But nevertheless, whatever happens here is that we can get the data in order and structure everything so that it's ready for display. Also set up some components of any kind. And that's what happened, which also is, if we implement this correctly, I don't think I will ever have to use any loaders anymore, you know? So that's a good thing right there. So that's a few of the things that I wanted to show. I didn't go through the await as a logic block, and I didn't take a closer look at the slots really, but they're pretty easy and straightforward, so I suggest that you just take a look at it if you're interested. Some other stuff, some references that I have here is of course this is a talk from Rich Harris about rethinking reactivity, the official Svelte website, the official Sapper website, another video here called Futuristic Web Development. I really suggest you take a look at that. And I think that quite possibly the future will bear in hand a front-end frameworks that always consider static site generation and server-side rendering as a part of the framework. I sincerely doubt that Next, Nuxt, Sapper, and Gatsby and all of those will be available, or even not be a part of the original framework, so to speak. I don't think they'll be on top of them or aside from them, or actually be all together as one. A Svelte compiler handbook, very interesting if you want to dig a little bit deeper into how Svelte actually works and how the compiler works. Then some other stuff here on the to the right that you can just take a look at. I truly recommend these resources if you want to dig a little bit deeper and if you're interested in Svelte. So I don't want to take too long. I just want to say thank you very much for listening and hope to see you soon again. Bye bye.